section 9-6, secants, tangents, and angle measures. First thing that we need to do is define what a secant is. A secant is a line that intersects a circle in exactly 2 points. Okay, so given a circle, it's a beautiful circle, we got a secant right here. This line, line L, would be considered a secant since it intersects the circle at exactly 2 points. Now you want to remember that if the line intersects at exactly 1 point, it's no longer considered a secant, it's considered a tangent. Okay, so if line L sort of moved down this way and intersected right here, okay, so this is a new line L, okay, now this would be considered a tangent. Okay, so now that we know what a secant is, let's look at some theorems. Okay, the first theorem that we're looking at, if a secant and a tangent intersect at the point of tangency, then the angle formed is half the measure of the intercepted arc. Okay, let's pull those pieces apart. So if a secant, so line AC, or in this case ray AC, is considered a secant, it intersects this circle at exactly 2 points. And a tangent, line TC, intersects this circle at exactly 1 point. And if they intersect at the point of tangency, so C would be considered the point of tangency, then the angle formed, so angle TCA right here, that angle, is half the measure of the intercepted arc. So the intercepted arc is right there. So if this intercepted arc was, say, let's make something up, 50 degrees, then angle TCA would be half of 50 degrees, which would be 25 degrees. Okay, so that's the first theorem. I skipped one. So the second theorem, if two secants intersect inside a circle, then the measure of an angle formed is half the sum of the two intercepted arcs. So here in this diagram, we have two secants. We have line RT and we have line SU. Both of them intersect this circle at 2 points. Okay, so they intersect the circle at 2 points, and those two secants are they themselves intersecting inside the circle. Okay, then the measure of one of these angles formed. So if we're looking at, say, the measure of angle 1, then that's equal to half the sum of the two intercepted arcs. So if we're looking at angle 1, this is the angle that we want. That is going to be half the sum of arc RU, so the measure of RU, and the measure of ST. Okay, so we're looking at these two arcs that are vertical to angle 1. Okay, look at the next theorem. Next theorem says if two secants or two tangents, or one of each, intersect outside of the circle, then the measure of the angle formed is half the positive difference of the two intercepted arcs. Okay, so there's a lot of information there. In every single case, these two lines, okay, in this case, we have two secants. Here we have one secant EF and a tangent DG. They are intersecting outside of the circle. And here we have two tangents that are intersecting outside of the circle. Okay. Now the angle that is formed with the point outside of the circle being the vertex. So here we're talking about angle A, in the middle example, angle D, and in the last example, angle H. That angle is equal to half the positive difference. So what you need to do is take this arc of CT and subtract arc BR. You're subtracting the smaller one from the larger one. Okay? And then whatever that difference is, take half of it and it's equal to that angle. And the same thing happens in each one of these examples. You take the difference of those two arc measures and then take half of that. And the last one, you do the same thing. The last one's a little bit weird because you're taking the major arc and you're subtracting the minor arc, that ends up being the entire circle. But the formula is still going to work exactly the same way. Okay, so now let's look at some examples. Okay, so example 1 says find the measure of angle S. So given this diagram, here we can see that arc BE is equal to 100 degrees. And this is a little confusing, but this is arc AR that is equal to 25 degrees. So what we're trying to do is to find angle S. Okay, right in here. That's supposed to be a little question mark. So let's do this the first way. Okay, actually a couple different ways of doing this. So one way that we could do it, let's find angle 2 to begin with. Okay, angle 2 is an inscribed angle. Its vertex is right on the circle. So an inscribed angle is half of the intercepted arc, which is 25 degrees. So angle 2 is going to be half of 25 degrees, which is 12.5 degrees. Okay, so angle 2 is equal to 12.5 degrees. Okay, then we can go down here, we could find angle 3. Angle 3 is also an inscribed angle. Okay, its vertex is on the circle and its intercepted arc is BE. And angle 3 is half of BE, so it's half of 100 degrees, which is 50 degrees. Okay? And now we can then find this angle right here. That supplementary angle must be 130 degrees. Okay, because you want to remember these two angles, angle 3 and this angle that I marked in red, are supplementary. They add up to 180 degrees. So all you have to do is subtract 50 from 180, get 130. So now you have a triangle right here where we have triangle RSE, okay? And one of the angles in that triangle is 130 degrees. One of them is 12.5 degrees. Angle S is the unknown angle. So we're just going to add up 130 and 12.5. We get 142.5. And then we're going to subtract that from 180. And we get, what is this, 37.5. So that's our angle S. Okay, so that's one way of going about doing this. Another way, let's actually erase some of this. Um, Did not expect that to happen. Um, okay, let's reconstruct this diagram. Okay, not as pretty as it once was. Okay, what's important though is that we have this arc of 25 degrees and arc BE of 100 degrees. So our theorem said that angle S is going to equal half the positive difference of those two arcs. Okay, you want to remember this angle is outside of the circle, so we are finding the difference between the two arcs. So if we just subtract 25 from 100, we get 75. So angle S is equal to half of 75. Therefore, the measure of angle S is 37.5, the same exact answer that we got using inscribed angles and triangles. Okay, so this is a little bit shorter, but it requires knowledge of that theorem in 9-6. Let's look at another example. Okay, example 2. So here we're looking for x. Oh no, excuse me, I'm wrong. We're finding the measure of angle R, and we've got to sort of define what's going on here. We have line S or ray RS, and this is a secant. Okay, this right here is a secant. It's intercepting the circle in 2 points. And then we have ray PR, and ray PR is intersecting the circle at 1 point, so it's considered a tangent. And now we want to try to figure out what's going on. Well, these two intersect at R, and R is outside the circle. Okay, so we're going to use the same theorem that we just used in the last example. Okay, if a secant and a tangent intersect outside of the circle, then that angle, angle R, is equal to half the positive difference of those two arcs. Okay, so now let's just fill in the pieces here. Okay, we know angle R as a measure of x plus 2.5. And we have an arc of 50 degrees, which we're going to subtract from the larger arc of 4x plus 5. Okay, and I'm not going to put 4x plus 5 in parentheses just because it's the leading term. It's not affected by this subtraction sign. And now we have to solve this mess. So let's do a little bit of algebra. Okay. Let's first combine like terms. So we have half of 4x minus 45. Then we're going to distribute that half. Okay. And we get 2x minus 22.5. And then I'm going to subtract x on both sides. So we get x equals, and I'm going to add 22.5 on both sides. I'm sort of doing this in one step because I'm going to run out of room. So we get x is equal to 45. Okay, now this isn't our answer because they want us to find angle R. We just found x. So we're going to take this and substitute it back in here. So angle R is equal to 45 plus 2.5, which is 47.5 degrees. There's our answer. That's the measure of angle R. Okay, and now we have one more example, I believe. Yes. So now we're looking for angle Y. So here we have WI intersecting the circle at one point, so this is a tangent line. Here we have ray BI, or IB, excuse me, intersecting the circle at one point, so this is a tangent. And they've given us angle I, the angle that's formed by those two tangents that are intersecting at an exterior point outside of the circle. So we're going to use our theorem, and our theorem says that if they intersect outside of the circle, we have to take half of the positive difference. So the measure of angle I is equal to half the difference of the two intercepted arcs. So angle I we know is 28 degrees. And this is a little bit tricky here. Okay, looks like y is the smaller arc, so we're going to subtract y. But now we need an expression for that arc. Okay, well, we can clearly see that arc WEB added to arc WB is equal to the entire circle, which is going to equal 360 degrees. So if one of those arcs is y, this other arc must be 360 minus y. Okay, so just little example, if y was equal to 1 degree, then the other part of the circle must be equal to 359 degrees. Okay, 360 minus 1. So that's how that's going to work. So then we're doing 360 minus y. Okay, and now we just have to do some math. We have 28 equals half of 360 minus 2y. I'm just combining like terms. And I'm distributing the half, so we have 28 equals 180 minus y. Now we're just going to solve this, subtract 28 on both sides, and add y to both sides. So now we have y is equal to 152, 152 degrees. Okay, so that's the end of this video. Hopefully this is enough to guide you through the homework for section 9-6.